Hey mathematics learners, welcome to Distance Learning with Lee, where I make learning mathematics super easy. So on today's video tutorial, guys, I'm going to be showing you guys how the quadratic formula, right, came about, okay? So in all the video tutorials that we've done thus far, I've been showing you guys how we basically need to solve for x or solve a quadratic equation by completing the square, okay? In this video tutorial, right, we're going to be still solving a quadratic equation, okay? But in this case, the quadratic equation that we're going to be solving is a quadratic equation of the form ax squared plus bx plus c, which is equal to 0, okay? So we're going to solve this quadratic equation for x by completing the square, okay? And by doing that, right, we will actually be deriving this quadratic formula, because it's very important that before we even start off with a section, we understand how did they get to this quadratic formula? Where does this quadratic formula come from? Okay, so that is basically the purpose of this lesson. Okay, I'm going to show you guys how this quadratic formula was basically derived from basically solving, okay, the quadratic equation of the form of ax squared plus bx plus c for x by completing the square. Okay, so before we get started with today's video tutorial, guys, please make sure that you are subscribed to the channel. Please make sure that you click on that notification bell so that you get notified every single time I upload a video tutorial, guys. And also please don't forget to give this video tutorial a huge thumbs up, because it really helps the channel grow, guys, and it helps the channel to reach more learners that want to better their mathematics marks. Okay, so without any further ado, guys, let's get started with today's video. Okay, so let's have a look at this question, right? It says, by completing the square, show that the solution of any quadratic equation, right, of the form of ax squared plus bx plus c is equal to 0, where a is not equal to 0, can be determined by using the formula. X is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so basically what this question is asking us to do is for us to prove, right, that the solution to this equation is equal to x is equal to minus b plus minus b squared minus 4ac, the square root of b squared minus 4ac all over 2a. So that is basically what we want to do. Okay, so here, guys, we're going to be applying all the steps that I've basically been showing you guys on how we go about completing the square. So we're still going to be applying those steps, right? We're still going to be applying that method that I've been showing you in the previous video tutorials to basically complete the square. So I'm going to rewrite this equation on the next page. Right, so we're given the equation ax squared plus bx plus c, and we want to solve this quadratic equation, right, for x by completing the square, okay? All right, so we're given the equation of ax squared plus bx plus c, which is equal to 0, right? And we want to solve this quadratic equation for x by completing the square. Okay, so from the methods or from the steps that we did together, okay, what's that first thing that we need to do? Okay, what are we noticing? We want to divide every term of this equation by a, right? And once we've basically divided every term of this equation by a, we'll be more than ready to basically get started with completing the square. Okay, so let's do that. We're going to divide every term by a. So I'm going to write the solution in green. I'm going to divide every term by a, divide positive bx by a, divide positive c by a, divide 0 by a. Okay, so by doing this, what will we have left? We'll have x squared, right, plus b over ax plus c over a is equal to 0 divided by any number is equal to 0. 0 divided by anything is equal to 0. Okay, right? So then now we see that, okay, our coefficient for x squared is what? Is 1. Okay, so now we can basically start off with start now with our solution. Okay, then now what do we also see? Remember, I did mention when we basically want to complete the square, we have to group all the terms with the variable x, right, on one side, and we want to have the constant term on its own on the other side. Okay, so what do we want to do in this case? We basically want to move the constant, okay, positive c over a. How do we know that in this case, right, in this situation, this is our constant? Because it doesn't have that variable x. Okay, so it's our constant, okay, for this equation. So therefore we now want to move that positive c over a to the right hand side, and when we move it to the right hand side, it will become a negative c over a. So now we've got x squared plus b over a x, okay, which is equal to minus c over a. Right, so now this equation is in that standard form that we want it to be in, right? And now we can basically get started with completing our square. Okay, so once our equation is in this form, what did we look at? Right, we looked at the coefficient of your x. Okay, and in this case, the coefficient of x, right, is b over a. Okay, so we're going to take that positive b over a. Okay, what did we do with that coefficient of x, right? So we basically took that b over a. I'm going to show you guys here on the side. Remember, we took that b over a. It's a positive, right, in this case, right? We took that b over a and we divided that by 2. So we took the coefficient of x, we divided by 2, and we squared it. Okay, and we said that now this value, right, is the value that we're going to add to the left hand side and add to the right hand side. Okay, but I also just want to show you something. Okay, we can also say now, because you guys know that by me saying we're dividing it by 2, that's the same as saying we're basically taking that b over a and we're multiplying it by 1 over 2, right? Do you guys see that? Okay, so we can also just now, because I've basically shown you guys what we actually doing, I think at this point you guys see that, okay, if I say b over a divided by 2, that's the same as me saying, okay, b over a multiplied by 2. Because if I say b over a divided by 2, how would I write that? It's like saying b over a if you divide it by 2. Okay, what do you see here? What's happening? That's the same as saying, okay, b over a multiplied by 1 over 2. Okay, so that's basically the same thing. All right, okay, so then from here, okay, that's basically what we are going to add. This is basically the term that we're going to add to the right hand side and add to the left hand side. Okay, so now let's just simplify this further, guys. B times 1 is b, right? B, and then a times 2 is 2a all squared. Okay, so this is the term that we're going to add to the left hand side and the right hand side, right? So let's just do that now. Let's add this term to the right hand side. Let's add it to the left hand side, right? So now we've got x squared plus, we're going to keep that b over ax. Okay, then we're going to plus, right? We're going to plus that b over 2a all squared, that b over 2a all squared, right? Which is equal to, we're going to keep that negative c over a. We're going to plus, right? We're going to plus, right? That b over 2a all squared. Okay, so then now, guys, okay, so basically what we want to do on the left hand side, remember now, we want to now factorize, right, the left hand side. How did we factorize the left hand side, right? We open the brackets. We already see that we've got a perfect square trinomial. Why am I saying we've got a perfect square trinomial, right? Because if you square the square roots, the x squared, you'll get x, right? If you square root the positive b squared, b over 2a all squared, you'll just get b over 2a, okay? So in that case, right, okay, the terms, when we factorize then this equation, it'll just be x, right, plus, because all of these terms are positive, b over 2a all squared, okay? The other method that I spoke about, right, on how you basically need to factorize your left hand side, I did mention, right? You just take your x, right? And then this sign here, it's a positive, okay? Remember, this was a positive b over a. So you just take your positive, right? B over 2a, right? This value, you write it just the way that it is. The value that is inside your bracket, right? You write it just the way that it is, okay? Your positive b over 2a, okay, all squared. And that is equal to negative c over a plus, let us just simplify this bracket here. It's going to be b squared, okay, over 2 times 2 to the power of 2 is 4, and 8 to the power of 2 is 8 to the power of 2, okay? So then, what do we notice now? We factorize the left-hand side, right? We need to simplify the right-hand side. So here, guys, we're working with unknowns. We're working with C's. We're working with an A. We're working with a B, right? We're working with unknowns. But we still applying all our mathematical concepts, right? Before we add fractions, what do we basically need to ensure? We need to ensure that our denominators are the same, okay? So here, we're just going to write that x plus b over 2a all squared is equal to, we want to basically sort out our right hand side, right? Okay, so in this case, we can see that our denominators are not the same. We've got 4a squared, we've got an a here, okay? So in this case, we know we need to find the lowest common denominator, okay? So in this case, right, we can see that, okay, we've got an a for the denominator for negative c, and here we've got 4a squared for the denominator for b squared, okay? So what are we noticing? What is going to be our lowest common denominator, okay? So just pay attention here, right? In this case, for negative c, right, we've got the denominator of a, right? And for your a squared, for your b squared, we've got your denominator of 4a squared. So in this case, it's the same as just saying 4 times a times a, okay? So what do we see then, okay? For us to have the same denominator for our negative c, we need to multiply the numerator and the denominator, right, by what? What is missing? By 4a, okay? So in this case, right, we are just going to multiply the negative c by 4a. We're going to multiply that a by 4a, okay? Because if I multiply the a by 4a, I will then have 4a squared, okay? So in this case now, we're going to have negative 4ac as our numerator divided by 4a squared, okay? Plus b squared over 4a squared. Okay, so now this is nice, right? All that we need to do, we can see that our denominators are the same, so we can further on simplify our right hand side. We are still keeping the left hand side the way that it is, right? So it's b over 2a all squared, which is equal to, we can basically now add our numerators because our denominators are the same, okay? So it's going to be negative 4ac plus b squared, all divided by 4a squared, okay? Right? And then now, what did we do? What was the other step now? We've already simplified our right-hand side. We've already factorized our left-hand side. What did we do then? From here, we basically square rooted, okay, both the left-hand side and the right-hand side. Remember, okay? So here we are going to square root, okay, the left-hand side. We're going to square root the right hand side. Remember, guys, we are trying to solve for x. We want to have our final answer as x is equal to something. Okay, so if you square root your left hand side, what do you have now? Right, on your left hand side, you will just have x plus, right, b over 2a is equal to, we can, do you guys agree that, okay, we can basically write the right hand side as the square root of negative 4ac plus b squared all over 4a squared. You can also write that as the square root of negative 4ac plus b squared all over the square root of 4a squared. Do you guys agree? We can actually write it like that, no? Right? So therefore then, we can't basically simplify the numerator any further. Remember, the square root of any value will give us a plus and a minus, okay? Then we can't basically simplify your numerator any further, okay? Because we've got that plus in between those two terms there. So we cannot simplify this any further, okay? So we are just going to have your negative 4ac plus, okay, b squared. What about the denominator? Can I simplify the denominator any further? Yes, I can, okay? What is the square root? What is the square root of 4a squared? The square root of 4 is 2. The square root of 2, the square root of a squared is just a. Do you guys see that we are slowly but surely getting to our quadratic formula? Do you guys see that? Okay, so from here, what do we still need to do? I'm just going to do this now. Okay, right? So from here, what do we still need to do? We basically need to take that positive b over 2a to the right hand side. Okay, so x is equal to, right? If we take it to the right hand side, okay, we're going to have minus b over 2a. Okay, what do we already have on the right hand side? Plus or minus? Plus minus, okay, the square root of negative 4ac plus b squared, right, all over 2a. Okay, so here, guys, what do you already see? Okay, we see that our denominators are the same. We've got 2a here, we've got 2a here, right? So then we can basically add our numerators. Okay, so therefore your x is going to be equal to minus b plus or minus the square root of, okay, we can just also just swap these terms around. Okay, that is still okay. We're going to just have b squared because it's a positive b squared minus 4ac all over, okay, all over 2a. All right, and then, guys, what are you noticing? We have actually derived the quadratic formula. We've basically proven that the solution of any quadratic equation, right, that is in the form of ax squared, right, plus bx plus c can be determined by using the formula of x is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. So do you see that actually the method that we've been using of basically completing the square, right, is absolutely correct, okay? Because we were able to even just derive or show how the quadratic formula was basically formulated. How did they get to this as our quadratic formula? They got to that by actually solving this equation, by solving this quadratic equation, right, for x by completing the square. Okay, so I thought this was going to be actually a great and amazing lesson, especially if you are learners that want to go into the fields of engineering, if you want to do your BScs, right, if you want to be a person that specializes in mathematics, right? If you want to be a mathematician, you need to start getting into the habit of deriving equations, deriving formulas. How did they get to a particular formula? And you guys will come to realize in my equations, I love to do derivations because I want you guys to understand how did a particular formula come about. Okay, so that was the whole point of this video tutorial for today, to show you guys how did they actually get to this quadratic formula, right? And why can we actually solve quadratic equations of the form of ax squared plus bx plus c by actually using this formula. Okay, so we've basically proven that. Okay, so in the next video tutorials, guys, I'm going to be showing you guys how we can now use the quadratic formula, okay, to basically solve quadratic equations for x. Okay, so that is it for today's video tutorial, guys. I hope you guys enjoyed this nice, great derivation. Sit down, okay, actually do it and understand where certain formulas come from. Okay, in the next video tutorial, guys, I'm going to be showing you guys now how we can apply this quadratic formula, right, to help us now solve a quadratic equation for x. That is it, guys, and I'll see you guys on my next upload, Distance Learning with Lee, where I make learning mathematics super easy. Bye, guys.